In section 10.3, we're going to be working on verifying trigonometric identities. Just going to be working with some rules about trigonometric functions and simplifying expressions and verifying identities. And key vocabulary here is talking about trigonometric functions. A trigonometric identity is an identity that is true for all circumstances. So it would be different from an equation, which is true under a specific circumstance, but a trigonometric identity is always true. So we'll talk about the difference between those in a little bit. The type of problem I might want to work on is something along this line. The vertical gnomon, that's the part of the sundial that projects the shadow, so that's this part right here, has a height of h, so when we start talking about this, this would be the height. And then the length s, that's over here, running along this direction, is the shadow cast by the gnomon when the angle of the sun above the horizon is theta. In this case, this is theta here, right? So for an unknown angle. So then we'd want to prove that the equation is equal to this other equation. S is equal to h cotangent of theta, the height times the cotangent of theta. So what that's going to involve is reworking this part of the equation to make it equal to that, which is what we do typically when we prove identities. The rules we're going to be working with are these. Some of them you already know. For instance, the reciprocal identities you should already know. Cosecant is the inverse of sine, secant is the inverse of cosine, and cotangent is the inverse of tangent. You should also know these. Tangent of theta is sine over cosine, and cotangent of theta, since it's the inverse of tangent, is cosine over sine. And then we've got some new rules that you haven't seen before. So the Pythagorean identities, so they look like a squared plus b squared equals c squared, is the sine squared of theta plus the cosine squared of theta is equal to 1. 1 plus tangent squared theta is equal to secant squared theta. 1 plus cotangent squared theta is equal to secant squared theta. Right? So we have these three new identities to be working with. Then we have cofunction identities, and they actually are sort of an offshoot of something we've already talked about. Sine of pi over 2 minus theta is equal to cosine of theta. And this is something we talked about before in that supplemental angles, complementary angles, angles that add up to be 90, the sine is equal to the cosine. So we've talked about that when we talked about the unit circle. And that's what this is, right? Pi divided by 2, that's 90 degrees and it's expressed in radians. So these, in this case, your angle's always going to have to be working in radians if you want to evaluate this. So these are kind of an offshoot of something you already learned. And then here, negative angle identities deal with, again, the concept of what happens with the negative angle and in what quadrant would it be. The sine of the opposite of theta is going to be the opposite of sine of theta. Cosine of the opposite of theta will be equal to cosine. That's because sine is related to y. So if I'm talking about angles, and if I have an angle here, its negative angle would be there, they would be the same value, but this one would be positive and this one would be negative. Okay, so when I have a negative angle, then this would be the opposite of that. When we're talking about cosine, cosine is related to x, so in the same circumstance, right, if I had this angle and this angle, the x coordinates are the same, so the sine of this, cosine of this angle would be equal to the cosine of that angle. And then tangent, because it's the ratio of these twos, would be the negative sine over the positive cosine. That would be the opposite of tangent. So again, these are offshoots of things that we've kind of already learned. So when we look at doing work like this, one of the things they may ask us to do is to find the trigonometric values for a given interval. So they've given me an interval. I might do this by graphing. I might do it by using the unit circle. I might do any number of different things. But when we start looking for values of sine that equal 1/3, when we start talking about the unit circle, now 1/3 is not one of the measurements on the unit circle, but it could help me establish a range, right, at pi over 6 or 30 degrees. I know that my y-coordinate is 1/2 and my x-coordinate is radical 3 over 2. So we're talking about sine, that here it would be 1/2. And when I'm here, it would be root 2 over 2. And when I'm here, it would be root 3 over 2, would be the sine function, right? That, and that. So as I go from 30 to 45 to 60, so where would 1/3 be in all of this? Well, this is about 1/2, so it would be somewhere between, right? This is 1/2. It would be somewhere less than 1/2, right? Which would be down in this range down here. Okay, so I know it's somewhere in here between 0 and 30. Now I can also take and use the concept that sine squared theta plus cosine squared theta is equal to 1. The goal, by the way, in this problem is to write all 5 trig functions besides sine, which I already have. Now we did learn another way to do that, right? We learned that I know that sine would be y over r. Right? And I know that I could go ahead and I could use these values to work with this. That's how we did in another section. But let's go ahead and use this. I know that 1/3 squared plus cosine squared theta is equal to 1. 1/3 squared is 1/9 plus cosine squared theta is equal to 1. So that means that cosine squared theta is equal to 8/9, and that means that cosine of theta is equal to the square root of 8/9, or 2 root 2 over 3. Okay, so now I've got sine and I've got cosine. If I have sine is equal to 1/3, that means that cosecant is equal to 3. I have cosine is equal to 2 root 2 over 3, and that means that secant is going to be equal to, secant would be equal to 3 over 2 root 2, but I'd have to multiply this by root 2 over 2. So that'll be 3 root 2 over 4. And when we talk about tangent, let me move all this stuff out of the way so I have room. When I start talking about tangent, that's going to be sine over cosine. So that's going to be 1/3 divided by 2 root 2 over 3, which would be equal to this times the reciprocal. These guys will cancel. I'll have to multiply it by root 2 over 2, so that'll be root 2 over 4. So root 2 over 4. And then cotangent will be the inverse of that. So I can go back to this 3 over 2 root 2. That'll be 2 root 2 over 3. Again, let me make a little more room. Right, so remember, at this point, right, everything after this was me rationalizing the denominator. If I invert this now, I'm going to go ahead and get cotangent, 2 root 2 over 3. So by using this trig identity, I was able to go ahead and very quickly come up with all these different functions, all the different values for the different trig functions. Okay, so we learned other methods to go ahead and do this, but in this case, it was easy to do this. And then this is important because it's going to let me know about the signs in all of these. Remember, this means it's in quadrant 1. This is pi over 2, and everything here is positive. The y values are positive, the x values are positive. That means that the tangent's going to be positive as well. So go ahead and practice that. Try problems 4 and 5. Pick the appropriate one of these to work with based on what you're supplied. Right? You might work with cotangent squared if they supplied you cotangent. Might work with tangent. I might work with sine or cosine. Right? So you're going to look at these and use whichever one makes the most sense. Okay, now in this section we want to work with simplifying. Right? So I know that sine of x pretty much is just that, but cotangent can be expressed as cosine and sine. So cotangent, I know, is equal to the cosine of x over the sine of x, right, which we got from right here. Okay, and then when I go ahead and put cosine of x over sine of x, these will cancel, and it just simplifies to be cosine of x. Okay, when we look at this, there may be a few more things I want to do, but I know that cosecant is the inverse of sine. So I rewrite cosecant as the inverse of sine times sine plus cotangent squared theta. Something times its inverse is going to equal 1 plus cotangent squared theta. Well, that looks an awful lot like one of those Pythagorean identities. 1 plus cotangent squared is cosecant squared. So this will be cosecant squared theta. So what we're generally talking about doing with simplifying these guys is using these identities to rewrite and simplify so that we can get our expression to be as simple as possible. Okay, so go ahead and try that again. Do problems 13 through 15, and then come on back. When we talk about verifying identities, we're normally given an equation, and the key is this item right here. When verifying an identity, begin with the expression on one side, use algebraic and trigonometric properties to manipulate the expression until it's identical to the other side. So what you're doing is you're not working with both sides of this. It looks like an equation. You're not really going to work with both sides. The point is, I need to make this side of the equation become this. So I need to make it 1. And in this case, it's not that hard. I know that sine of x can be multiplied cosecant of x, which is 1 over sine. And sine times its inverse, 1 is equal to 1. And now I've verified my identity. Okay, something that's a little more complicated might look like this. Okay, so let's take a look at what we've got. So I know I've got these guys with the complementary angles. Cosine of pi over 2 minus theta, I think that's equal to sine. See, in cosine, it is. It's equal to sine, so I'm going to use this. And I'm going to replace that numerator with just sine of x, or actually sine of theta. We're using theta here. And 1 minus, well, I have a deal about negative angles, so let's take a look at negative angles. So the sine of the negative angle is the opposite of the sine of the angle. Okay. So that means that this is going to be 1 minus the opposite of sine of theta. Well, minus a negative is going to be plus, So I'll have 1 plus the sine of theta. I just reordered that over 1 plus the sine of theta. So something divided by itself is equal to 1. 1 equals 1. I'm done. Okay, so when you're talking about verifying an identity, the result at the end is known. We know it's going to be 1 is equal to 1 in this case, or that the left side of the equation is equal to the right side of the equation. What's important are the steps that you use. Okay, so go ahead and practice that, and then we'll work out that word problem about the sundial. Do problems 29 through 30, and then come back. So here we are, we're back to working with this gnomon. And so what I'm trying to do is I'm trying to prove that this is equal to h times cotangent of theta. So if s is equal to that, I can put it over here. H times cotangent of theta is equal to all of this, sine. Now remember, 90 degrees in radians is pi over 2. I'm doing that because it's going to look like other things we've got. Over sine of theta. And if we pop back and look at, right, sine of the complement of an angle, that's going to be equal to cosine, if you remember that. If you don't remember that, it's right here. Right? Sine times pi over 2 minus theta is equal to cosine of theta. So I'll have h times cosine of theta over sine of theta. Well, cosine of theta divided by sine of theta is cotangent of theta. So I'm going to pull the h out here, and cosine over sine is cotangent. Now remember, something in the numerator could always be pulled out. I have two things being multiplied. I could always pull one of them out and put it out here as a coefficient. So h times the cotangent of theta is equal to h times the cotangent of theta. I've proved my identity, and that's how you would go about solving a problem like this. That's it for this lesson.